Alright guys, so I'm going to put together this little video for you to do a couple of these Lewis structures that you're going to do over the weekend, just so you can get comfortable with it, and then hopefully you'll be good after a few practice problems. So let's start with number 2 that is on the chart. So it's HCN. Remember step 1, what you do is you count your valence electrons. So hydrogen has 1 valence electron, carbon has 4, and nitrogen has 5. So altogether you have 10 valence electrons to work with. So after that, your next step is to figure out who is the least electronegative and put it in the center. Remember that hydrogen can never go in the center. So carbon's going to go into the center here. We're going to attach a nitrogen and a hydrogen. So altogether, I used 2 electrons for the carbon-nitrogen bond and 2 electrons for the carbon-hydrogen bond. So 4 electrons altogether. So that means I have 6 to work with. So if I do that, I can try to put electrons around nitrogen to fulfill its octet. Do you see how I already ran out of these valence electrons? So due to that, I'm going to have to try to put some multiple bonds. So I'm going to erase what I've worked with so far. Let's erase how many bonds we've used. So now I'm going to try to put a double bond here. Well, now that's 2, 4, 6 electrons that I've used in the bond. I have 4 to work with. So if I put 1, 2, 3, 4 here, you see how carbon is still not fulfilled for its octet. So this is where I'm going to have to try to put a triple bond. So if I try to add a triple bond here, I now have used 2, 4, 6, 8 of those electrons in the bonds. So I have 2 left over. Carbon is already fulfilled in its octet because it has 8 around it. So I'm going to put the 2 electrons by this nitrogen, so now the nitrogen can have its octet fulfilled. Remember, you never add anything but 2 electrons to hydrogen because it does not follow the octet rule. It only needs 2 electrons. So this would be my valid Lewis structure. Now let's look at number 4. I'm just skipping around here and giving you guys some help with this. Number 4 is SO2. So the very first step is I count my valence electrons. So that is going to be 6 for sulfur plus 6 times 2 oxygens. So altogether I have 18 valence electrons to work with. The next step is I'm going to put the least electronegative into the center, and so that would be sulfur. I'm going to try to add my oxygens. So together I've used 4 electrons in my bonds. So 18 minus 4 would be 14 electrons to work with. So I try to put these 14 electrons around to where everyone's octet is fulfilled. So let's try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Looking at all of these, I have oxygen fulfilled on both sides, but you see how sulfur only has 2, 4, 6 electrons. So its octet is not fulfilled. So to help that, I say, all right, well, is sulfur and oxygen part of CNOPs? Can I get multiple bonds? And it is. Sulfur and oxygen can get multiple bonds. So let's try to, I'm going to erase these valence electrons. Let's try to put a double bond here. So if I try to put a double bond on one of these structures, that's 2, 4, 6 that has been used. 18 minus 6 is equal to 12 electrons. So I'm going to fulfill all the octets with the 12. So 1, 2, 3, 4. He only needs to get 4 because he already has 4. 5, 6, 7, 8, 9, 10. So now oxygen is fulfilled. And sulfur has 6, so the last 2 are going to go to the sulfur. So you see now how oxygen has a total of 8, sulfur has a total of 8, and oxygen has a total of 8 as well. So everyone's octet is fulfilled. Now, this is what we call the resonance structure. That means that this double bond here could also be drawn on the opposite side. So when you have that happen, you have to draw every structure that could be possible for this. You put brackets around that structure, you put double arrows saying that, hey, it can be drawn this way, and then I'm going to draw the other structure with the bond, double bond on this particular side. So my 2 electrons there, 2 electrons there, and 1, 2, 3, 4, 5, 6. So this whole thing would be the complete Lewis structure for SO2. Let's try another one that might give you some trouble. Let's look at number 11. So working with the number 11, it's SeCl4. I do the same process I've done for all of them. So Se has 6 valence electrons. Chlorine has 7, and there's 4 of those. So when I add all of those together, I get 34 valence electrons. I figure out who's the least electronegative out of here, which is Se. I'm going to attach 4 chlorines. And so altogether, I've used 2, 4, 6, 8 bonds. I'm sorry, not 8 bonds, but 8 electrons in my bonding. So 34 minus 8 is equal to 26 electrons to try to fulfill the octets. So I'm going to start filling up the octets for the chlorines because selenium is already happy. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So you see how I used 24 electrons, and all the chlorines have a fulfilled octet, and selenium is also fulfilled. But I have 2 electrons that's left over. Anytime this is the case, what I'm going to do is look at my central atom and see if it's in the 3rd energy level or greater. So selenium, if I look at it, it's in the 4th energy level. Since it's in the 4th energy level, then that means that selenium can have more than 8 electrons surrounding it. So these 2 electrons I'm going to put on the selenium, and that is a valid structure. So that's how you work the ones if you have remaining electrons left over after all of the octets are fulfilled. But this central atom right here has to be in the 3rd energy level or higher to be able to do that. One more I want to go through with you guys, and that's number 17. Number 17 is C2h4. Do the same process. Carbon is 4 times 2 plus 1 times 4. So my valence electrons altogether are 12. So now, the problem is that I have 2 carbons. How do I put them in the middle? Well, what I do here is I put both of them in the middle. So I know it's going to be a double bond, but when you guys work it out, you'll see that it's a double bond yourself. And this would be its structure. So that's all the time I have.